Alright, Algebra 2, we're moving to 9.5. I believe this is the last thing we're doing in the chapter. Geometric series. And our essential question is, what is a geometric series? Well, remember we talked about geometric sequences where the numbers went up by a multiplication factor. We call it a common ratio R. Okay? And now we're just going to take the sum of those. Okay? So that makes the geometric series. That formula for the sum of n number of terms would be the first term, a1, times, that's 1 minus r to the n. Make that a little better there. R to the n. Okay? All over 1 minus r. And that r is that common ratio. What are you multiplying by it to get it? And I'll show you. Here's an example. Find the sum of this geometric series. 3, 6, 12, all the way up to 3072. We're multiplying each term by 2 to get the next term, so that makes R2. Okay? Now our problem is we don't know what number term is that. Is it the 100th term, the 50th term? Let's find out. Just like we've been doing, we use the explicit formula, because remember the recursive, you need to know the one before it, and we don't. So the explicit formula to find n, so it's for a geometric sequence, it was a to the n equals a1 times r to the n minus 1. So I plug in my nth term. My a1 is 3. 2 is my r, we figured that out, and I got n minus 1. I divided out to 3, so I got 1024. And the thing to know here is this right here. And as we do some of these, you'll see some of the patterns here, but 2 to the 10th power is 1024. So if 2 to the 10th power is this, then 2 to the 10th equals 2 to the n minus 1. Well, then n minus 1 equals 10. Add the 1 over n is 11. So that term right there is the 11th term. So what's the sum of the first 11 terms? Starting with 3, 1 minus r to the 11th. I'm just plugging it into the formula up here now. 1 minus 2. So 3 times the negative 2047, which is what you get here, is negative 6141 divided by the negative 1, and you get a positive 6141. Okay, so geometric sum is right there. You got to use the explicit formula just like we did with the arithmetic series to find that nth term, and then once you know the nth term, you know r, you know your first term, just plug them in. Okay, and that's please excuse my dear Aunt Sally, calculator exercise. All right, let's look at another example here. Okay, an infinite series. What we just looked at is a finite. There's a last term. An infinite series is where it just starts adding them up and then it goes dot dot dot. It just keeps right on going. Okay. The thing to know about this is when you find that pattern, what you're multiplying by, that r, that common ratio, if that ratio is less than 1, the absolute value is less than 1, then that means we converge. Okay, we're getting closer to some number, usually a pretty large number. Okay, if that absolute value of that r is bigger than 1, like the one we just did, r was 2, then we say the series diverges. There's no sum. Okay, it's not getting close to any number. It's just off wherever. So when the r is less than or equal to 1, then that sum, that number that it's getting, that sum that it's getting closer to is just the first term over 1 minus r. Okay, an example would be like problem 3 on page 617. Tell us if it converges or diverges. Okay, so we look here, I've got 1 plus a half plus a fourth, and I see that I'm multiplying each term by a half to get the next term, so that's my r. Okay, I know it's an infinite series because it keeps on going. That's what makes it different than what we did on the other board. So that absolute value is less than 1, so we converge. So if it converges, then we can find the sum. What's it converging to? Well, that sum of numbers is converging to, and you can imagine, 1 plus a half is 1 1/2, then you go to 1 3/4, then you're going to add an eighth. So you keep adding smaller and smaller and smaller numbers. You're getting closer to some number, and that number is 2 when you add them all up. So, and you find that by taking the first term, 1, over 1 minus r, we said our r was a half. 1 over a half, that's the same as 1 divided by a half, or 1 times 2 over 1, because with division and fractions you reciprocal, change the multiplication. So it's 2. That sum would be 2 of those numbers. Okay? Let's take a look at another one here, another example. You have 2/3, negative 5/6, plus 5 over 24, and you try to figure out, wait a second, I don't see what the pattern is here. Okay? So what you can always do is, if it's multiplication going this way, then it's division coming back. So I'm going to take that first number and divide it by the second number and divide it by the first number. Okay? So I take the negative 5/6, division, we change the multiplication, then take the reciprocal of the second number, you flip it. That's negative 15 over 12, or negative 5/4. That's your R. I take the absolute value of it. The absolute value of a negative 5/4 is positive 5/4, which is 1 1/4. That's bigger than 1, so we diverge here. So there's no sum. You don't have to find a sum there. And you can kind of see here when you're adding and subtracting these numbers, they keep getting bigger for 1, and they keep changing signs. So you're going to be all over the place trying to figure out what that goes to. And that's why it diverges. It doesn't come to one number. Okay? So that's geometric series. You should be able to find the sum of a geometric series, a finite one. Use the explicit formula to find n, and then plug everything in. If it's an infinite series where it just goes dot, 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 keeps right on going, then look at r. If r is less than 1, the absolute value, then it converges, then you can find a sum. If the absolute value of r is bigger than 1, it diverges, no sum, you're done. Okay? We're going to look at some of that tomorrow and wrap this chapter up. All right, we'll see you then. Bye.